Hi, this is my tape and charge experiment for Module 6. In this project, I'll be showing how electric charges interact with each other. I'll identify the two types of charge, describe how charged objects can attract or repel, and test how distance affects those forces. I'll also explain what happened in my own experiment and why the results came out the way they did. When I brought my hand close to the tape, it didn't move at all. That means my tape didn't build up enough electric charge to show attraction or repulsion. Normally, a charged tape will move slightly toward a neutral object because it polarizes the charges in the object. But in my case, the tape stayed still, showing little or no charge buildup. When I brought the two tapes near each other, there was no noticeable movement. They neither pushed apart nor pulled apart. This suggests that the tape didn't pick up a measurable electric charge. If they had, we would expect them to repel if both had the same charge or attract if they had opposite charges. The lack of motion indicates that environmental factors like humidity or surface residue likely prevented the buildup of static electricity. I tried bringing the two T tapes near each other and then the two B tapes, but I didn't see any attraction or repulsion. I also tested the T tape and the B tape together, again, no visible effect. This means that my tapes either didn't get charged when separated or lost their charge before I could test them. This can happen if the air is humid or the surface isn't clean enough for static buildup. My analysis and explanation. 1. Minimum number of types of electric charge. Even though my experiment didn't show visible attraction or repulsion, I know from scientific evidence that there are two types of electric charge, positive and negative. In most successful tape experiments, some tapes attract and others repel, proving that two types exist. Number 2. Forces that electric charges exert on each other. When static charge builds up, like charges repel and opposite charges attract, my tapes didn't show those forces, but that's likely due to the lack of charge transfer rather than the absence of the effect itself. Number 3, force and distance relationship. Since my tapes didn't show visible forces, I couldn't measure how distance affects the strength. However, according to Coulomb's law, electric forces get weaker as the distance increases, even if it couldn't demonstrate that there. In this experiment, my tapes didn't attract or repel each other, so I didn't observe visible electric forces. This was likely due to environmental conditions or static not forming properly. Even though my setup didn't produce results, I still learned that there are two types of electric charge, positive and negative, and that their interactions depend on charge type and distance. The experiment helped me understand how scientists describe invisible forces by observing what we can see.